And now I'm going to show you a couple of other buildings that we've been working on. So this one's a factory, and handily, I have another piece of timber here. And this factory is made not from a bit of CLT and a bit of laminated veneer lumber, LVL. And laminated veneer lumber is interesting because it's made from a peeled tree. So rather than planks which are cut, it's made from peeling a tree. And the interesting thing about peeling a tree is when you peel a tree, you don't cut the cells. So timber, like glass, is made from long linear cells that run up the body. And if you cut it in planks, you inherently weaken it. Whereas if you peel it, it's a lot stronger. So this material is layers of that peeled timber stacked on top of each other. And this is a factory here. So you can see these are the beams for the factory. Here, they're 25 meters long. So 25 meters, it's probably a little bit longer than the depth of this theatre. And the whole beam is 450 mil. So a little bit shallower than it would have been if it had been in steel. So this is stronger than steel, this material. It's absolutely incredible. And what we're beginning to do is to learn to understand how we can work with this rudimentary material, bringing in different types of timber, carbon fiber, Kevlar, lots of different things in order to be able to strengthen this material in different ways. So we're using here hardwood in the CLT to give a strength on the shear walls, and then hardwood in the beams and the columns. And so you can see this is it's a factory, a library, and a ballet dancing studio. But you can only do that in timber. And then we're doing a cinema. So this is 5-story residential above a cinema, 3-screen cinema in Shoreditch in East London. We've got 3 projects like this. So this is a 1970s concrete office building, and we're building on top of it, behind it, in front of it, and we're using that existing concrete building to be like the kind of give the shear strength. So the kind of like it acts like a sort of concrete trunk, if you like, and we can build around it and on top of it. And then we can build in the snow, in the rain. And you know, in concrete, you can only use concrete above a certain temperature or below a certain temperature. So in timber, we can always build. And we're looking at hybrid structures. So this is one near my house. This is a 6-story building. And what we're doing is we're using a CLT core, CLT floor slabs, and then a steel frame to support the interior of the office. Honestly, the reason why we're doing this is because the client thought that people wouldn't find it so challenging if it had a little bit of steel in it. But actually, it's been slightly slower and slightly more expensive by doing it in steel. So it's like the first trains that they had? On the first trains, they used to put a carriage at the front with a horse on it to make people feel that it was okay. So we put a bit of concrete and steel in our buildings just to make people feel at ease. So that's it finished. We're working in Singapore and Madrid and New York and Paris now, so really kind of spreading our wings in terms of working in timber and talking to different manufacturers and different universities. We have research projects with the US Department of Agriculture, with Cambridge University, we've been at Yale and Harvard, so really branching out and beginning to understand what the implications are of what it is that we can do in terms of the architecture and the construction that we're working in timber with. We're working with other architects. So this is a project we're working with Shigeru Ban on. And so this is our town hall in London. In fact, the view that you're looking at now is taken from the Tower of London, looking over. So the mayor's office is here. So he's going to look down on our building and get inspiration. So this is like, for me, this is like going back to college, because this guy is obviously a master, a Pritzker Prize-winning architect, and I'm learning incredible amounts. Learning incredible amounts from somebody who is obviously that wonderful as an architect, but also, from different cultures and understanding of actually how different cultures work with timber and work with timber engineering. We're working with a Swiss timber engineer who's 120 years old, and he looks like Yoda from Star Wars. And he's kind of and he has these amazing ideas about. So one of the things that we're doing is there are big timber beams in the building, and they're all jointed together using hardwood dowel. And the way in which they do that is they get a microwave on site, and they put the hardwood dowel in the microwave for 5 seconds. All the moisture evaporates, the hardwood dowel shrinks down, they put it into the joint, and then the moisture soaks up from around it, and it's locked in tight. And when I went to a site of theirs in Switzerland, you just got microwaves pinging all over the site, like ping, 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 like that. And you get really hungry.